Okay. Lesson 7.2 continues with the graphing. You'll notice it says graphing families of exponential functions. So when we did our graphing in the previous lesson, it was usually just basically y equals a number raised to the power of x, right? We didn't get too fancy with it. There was one that had a stretch of 2 in homework, but we didn't get too fancy with it. So these, when we talk about families of exponential functions, we're going to look at the basic 2 to the x, 3 to the x, 5 to the x, whatever it is. But then we're also going to look at our other transformations. And so this would be like setting up an xy chart and then applying those transformations. So all of these exponential functions we work with are going to fit the form y equals b to the x, okay, where b is some number. And realizing the reason we're talking about exponential functions is because the x is in the exponent. That's what makes it an exponential function. Now, y equals a times b to the x. So what happens if there is an a value out front? Well, we often talk about when you multiply by a number out front, it is what? If you multiply by a number value out front, it's either going to stretch or compress. The word is shrink here. That's why I wasn't sure. And I don't care what you say, shrink or compress, okay? And so what they went ahead in this lesson and put all together, what if that a value is negative? That means there's also going to be a reflection, right? So if the a value is negative, there's a reflection across the x-axis, which just means it would be upside down. If it says the absolute value of a is greater than 0, so in other words, forgetting the sign, if the positive value of a is bigger than 0, it is a stretch. If forgetting the sign, the number is, that shouldn't say 0. Not 0. A 1, yes? Because when we talk about shrinks and stretches, or compresses and stretches, it's in reference to the number 1. Yes, please correct me, Jayden, because I was just talking. I was like, wait a minute. I didn't catch it until I got to the second one. Okay, so just like previously, 1, right? The number 1. If it's a number bigger than 1, it's going to stretch. If it's a number smaller than 1, it's going to shrink. And when I say smaller than 1, we're talking about a number between 0 and 1, right? The negative makes it a reflection. Okay, so old news, just a new function. Notice the next one. Y equals a times b to the x plus or minus h. Well, I know you've probably already read, but think about it. Where is that number being added or subtracted to? The x value, right? And I keep saying when the number is directly being added or subtracted to the x, then that means the graph is going to move left or right, and just like previous, opposite the sign. Okay, so this is equivalent to like if the number is under the radical, okay, or in the absolute value. I'm trying to think what are the different ones we've done. If it's in the exponent up there, okay, it's in the exponent, it's left or right, and it's still opposite the sign. No, if it's plus h, we're going to go left. If it's minus h, we're going to go right. And then the third part, what if it's a, b to the x, and then plus or minus k, and that k is not in the exponent? If it's just added or subtracted on at the end of the equation, we're going to go where? Up or down. Notice if it's a plus k, we go up k. If it's a minus k, we go down k. So when you're going up and down, it's still the direction of the sign. Does this sound familiar? We've done all this stuff, right? Like, these are still the same old transformations. It's just a new function that we're working with here. Now, let's look at example A. As I said, we're doing about every other graph here. I'm not doing all of them. So let's look at example A. Graph each of the following and what translations affected the parent function. So we have y equals negative 1/3 times 3 to the x. So what transformations do you see here? Hello?
Yeah. Bye. Kate and Eli. Mrs. Cook wants you for a couple minutes in the guidance.
You're coming back. Couple minutes, she better be sending you back. Otherwise, that's a big fat lie. She said couple minutes, so that was not, can I have them for the rest of the period? So, yes, it's relaying some information about vocational. Okay, transformations. What do we have here? Kendra? Okay, a negative sign, right? A negative sign says we're going to reflect across the x-axis. What else do we have going on? Multiplying by 1/3, which is a number less than 1, not 0, 1. That is a shrink. So I'm going to go ahead and write this at the bottom, just so, because it did say what translations. So it's a reflect across the x-axis and shrink or compress, I don't care what you say, by a factor of 1/3. And then we actually have to graph these, yes? Because it is a shrink or stretch. My recommendation here, there's no moving it up or down. There's no moving it left or right. Because it's just a shrink or stretch, I would say we probably should just talk about an XY chart. Okay? Because you're at least going to have to get the basic XY chart to begin with. What does an XY chart for 3 to the X look like? But then on top of it, you're then going to have to shrink it by 1/3. And so I'm going to go with an XY chart if you guys don't mind. What are your guesses that I'm going to want in for my X values? No. Multiples of 3 would make this 3 to the X, because it's an exponent, go huge quickly. You see what I'm saying? Even though I get that we're going to divide by 3, but it's a different beast when you have an exponent. What are the traditional ones we used?
Do you want to do -3 or
We'll just go we'll probably just go to the -2.
Okay.
So -2, -1, 0, 1, 2. You could go 3. I don't know. It gets kind of big kind of quick when you're doing 3 to a 3rd power, right? Now, again, because we're going to do a 1/3 of something, though, that would make it a little bit better. Should we start with the positive 1 first? Or do you guys care? Should we just start with the negative 1? Start with the positive, work our way to the harder stuff? Okay. I'll be honest. I'm not going to do graph B. How do you feel about me doing some work over here? So it's -1/3 times 3 to the 2nd. You see what I'm writing over there? Just my workspace. So if it's -1/3 times 3 to the 2nd, what is 3 to the 2nd? 9. So then, what is -1/3 times 9? What is 1/3 of 9? 1/3 of 9 is 3. A negative times a positive makes it a -3. And so that's why I say, yes, we could have gone to that 3 that Carter was asking about, but are we okay with that? I mean, some of the hardest part of this is making sure we understand the math. Yes? That's the 2. That's me plugging this 2 in here. I get it. Okay, let's plug in 1. negative 1/3 times 3 to the first. Well, 3 to the first is 3. So negative 1/3 times 3. What is a third of 3? 1. Negative times positive? Negative 1. Okay. Plug in 0. Negative 1/3 times 3 to the 0. What is anything raised to the 0? 1. So then you're doing negative 1/3 times 1, which is negative 1/3. Okay. Put in the negative 1. We got to do those negatives now. You got your warm-up time. Negative 1/3 times 3 to the negative first. How do I deal with 3 to the negative first? What do we do with the negative exponent? Put it in a fraction, right? A negative exponent to become positive moves to the denominator. So we already have the negative 1/3 out there first. 3 to the negative first is 1/3. I should have set this up better. Oh well. Negative 1/3 times positive 1/3 is negative 1/9. You can probably, well, I say you can maybe guess what the next one's going to be, but negative 1/3 times 3 to the negative second. What does 3 to the negative second mean? 1/9, or 1/3 squared. And so if I say negative 1/3 times 1/9, that's going to be negative 1/27. Yes?
I just got to ask, are we just doing the work for problem 1 in the box?
Yes.
Okay.
Yes. I stated that while you weren't in the room, we're graphing problem A right now. I'm not going to do problem B, so I'm using that space to my advantage. Yeah. So you don't look at this later and think, why was I using 3s and there's a 5s in the problem? Okay. We don't have any translations left, right, up, down. So at this point, graph it. Now, what can you expect this graph to do? Okay, exponentially grow. What did the negative cause this graph to do? Instead of going up, we're going to be going down. Okay, so now, these graphs are horrible. Period, end of statement. Okay? Just know that I would never give you a graph this horrible on the test. And when I'm talking about the graph, I'm talking about the physical representation of the graph, right? It's bad. Just deal. Okay, left 2, down, nothing. Okay, down, negative 127. Left 1, down a teeny bit more than that. Last one of negative 1/9. 0, negative a third. Left to right 0 and down a third. 1, negative 1. Right 1, down 1. 2, negative 3. Right 2, down 3. Can you see the shape your graph is taking? Okay, even though the points aren't the best because the grid isn't the best. The graph is going to run along the bottom of the x-axis, and then it's going down that way. Yes. In an already very tiny box, you have to go 127. Okay, questions on what I did there? Okay. The next one I'm going to look at is going to be C. Yes. We're going to look at C. And going off of my current plan, we will not be doing D right there. I told you, we're doing about every other graph. We're doing one of every two graphs. But I am going to make sure I cover everything. So, okay. Y equals 2 to the x minus 4. What are your thoughts here? What can you identify that's going to be happening? What do you think? She says it's going to move right. This minus 4 is in the exponent, yes? So it's on the x, in the exponent, which means left or right, opposite the sign. So a minus 4 does mean that this is going to go right 4. I'm going to use the official word and say translates right 4. I guess officially I should say right 4 units. You could say shifts right 4. You could say moves right 4. Just my pet peeve, don't just say right 4. What are you doing right 4? Okay? Now, on this particular problem, and this is the type that is especially important to think about this. I would not recommend just doing an XY chart for the whole problem. Because if you just do an XY chart for -2 through +2, and you just plug them in here, you're going to get a whole bunch of very small decimals or fractions, and you're not going to be able to tell the shape of the graph and where it's going. And so my recommendation, what is it we're going to move right for? We're going to move that y equals 2x right 4, yes? So my recommendation is that we get an xy chart for 2 to the x, and then move that xy chart right 4. That's my recommendation of what we do here. And until you truly experience it on your own, some of you won't really believe me. You'll have to find out on your own. But I'll try and explain why I'm suggesting that. Okay? So, XY chart. What X values am I going to use? -2 through +2. Now, when I do Y, though, what is this going to be? I'm not doing Y to the 2x minus 4. I'm doing Y equals 2 to the x. Okay? So forget the -4 for a moment. Just 2 to the x. So, if we put in, do I dare start in the negatives? If we put in -2, what is 2 to the -2? How do you get rid of that negative exponent? Make it 1 over 2 to the +2nd, which makes this what? 1/4. What about 2 to the -1st? Negative exponent says to move it to the denominator. What is 1 over 2 to the 1st? 1/2. I'm done showing my work now. What is 2 to the 0? Anything to the 0 is 1. What is 2 to the 1st? 2. What is 2 to the 2nd? 4. So my recommendation is you graph these dots, and then after you graph these dots, we're going to take these dots and do what with them? move them right 4. So, negative 2, 1/4. So left 2, up a teeny bit. Negative 1/2, left 1, up a half. 0, 1, left to right 0, up 1. 1, 2, right 1, up 2. 2, 4, right 2, up 4. Are those my final answer? No. And I don't, maybe you'll find a way and you didn't actually write those dots down. That's your choice. What do I do with each of those dots? Move them right 4. Which is next to impossible. I get it. Just deal. Okay? You end up having a dot at 6, 4, 5, 2. Instead of 0, 1, it's going to be at 4, 1. Instead of negative 1, 1/2, it's going to be at 3, 1/2. And 2, 1/4. And then the only dots you need to connect are your final set of dots. Now, with that in mind, and I don't know if I can accurately show this, if you had just done negative 2 to positive 2 with the XY chart, look at my pink line. Do you see what I would have gotten as the graph? I wouldn't have had any of the dots really moving up to show me how my graph goes up. It would have looked almost like a straight line. And that's why we need to do the 2 to the x only and then move the dots right 4. Because otherwise we would have gotten dots right in there on the pink line. And they would have just been like a line. Do you understand what I'm saying there? I don't know. It might be something that makes more sense once you actually make the mistake. Did you have a question, Clayton? Okay. Okay. Questions on that one? Okay. On the back side, we're going to do what is labeled graph E. Technically, if it was labeled correctly, it'd be graph F, but you know. We're going to do the one that looks more complicated. Well, if we just do D, y equals 4 times x, 4 to the x plus 2, that's a lot like the one we just did. What we haven't done, we've reflected something, we've shrunk something, which takes care of stretch and shrink. We've moved left, right, but we haven't done any moving up or down. So we've got to have something with up or down. Okay, so let's talk about the transformations. What are the transformations you see? Okay, this 5 out front is going to represent a stretch. You can't see that I wrote the word stretch, but I promise I did. What else? Okay, this plus 5 at the end is going to show. It's going to translate us up 5. Shift us up 5 is, I think, what was trying to come out of my mouth, but not happening. Okay, so if I put those in good words here, we're going to have a vertical stretch by a factor of 5, translated up 5 units. Now, I have a couple of different ways we could do this. I'll be honest. Because there is no left-right movement, you could put this whole equation, come up with your XY chart, and put the whole equation into the XY chart. That would work because there's no left-right movement. The left-right movement is what messes that up if we try and use an XY chart. Now, what I was going to do, because my recommendation is, go ahead and make an XY chart for this first part, and then after you get those dots, we can take each dot and do what with it? Move it up 5. That's my recommendation, okay? So I'm going to suggest we take this piece and we make an XY chart. So for my Y, it's going to be doing the 5 times 0.25 to the X. You know what X values I'm using, right? -2 to +2. Now, because it's a decimal, you could go calculator route if you want. The other option, 0.25 is what is a fraction? 1/4. You could do that as well. If you want to save time, practice with your calculator here. Okay, I'm saying that you could go fraction. You could do this without a calculator. Do you know how to enter this on your calculator? 5 times 0.25 raised to the, -2. You know how to do that? Yes? Not that it's difficult, but the whole point is know how to use the calculator. And yes, we get an answer of 80. We're going to be scaling this graph a little bit. Okay, what happens when you put in -1? You get 20. Here, challenge yourself without the calculator. 0. 0.25 raised to 0 is 1. Times 5 is going to make it 5. I get it. Teamwork here. What about 1? Okay, the calculator gives you the answer 1.25. Officially, if you used just the fraction, it'd be 5/4, because you'd move to the 4 to the denominator and 5/4. What about 2? .3125, which so happens to be 5/16. I'm not doing the +5 right now. Now, and there's a couple different ways you can do this. And I don't know, maybe I'm making it the more difficult way, but I have my reasons for what I'm doing. But you can take these, and then after you graph these, move each dot up 5, right? As you're graphing, you can graph it and then just go ahead and move up 5. Now, keep in mind, okay, -2, -1, 0, 1, 2, those are a piece of cake. How high do we have to go here? 80, and then technically up 5 from that. Okay, right? So, what I ended up doing to scale my graph, because keep in mind, when you scale a graph, you always label to show, yes? You can't just randomly scale it and then not tell me what you're scaling it, because that doesn't really work. I basically made each line worth 5. And so that means, and when I labeled it, then I did every other line. And I didn't go all the way over to the edge. I just kind of went here about where it was kind of out of my way, but yet close. So if the first line is 5, then the second line is 10. 15, I'm going to label 20. 25, label 30. 35, label 40. 45, labeling 50. 55, labeling 60. I feel like I got off somewhere. No, I didn't. Labeling 70. And if you've done this correct, yeah, we're a slight bit shy, but your top line is 80. Okay? If you scaled it differently, that's fine. I was just trying to give us some room to work here. So, Negative 280 means I'm going left 2, up 80. Negative 120, left 1 and up 20, which is basically up 4 lines. 0.5, which is only up 1 line. 1 5/4. So that's going to be right 1. And if you're going up 1.25, well, that's basically like about 1/5 of a box, isn't it? So a little small. And then 2.3125, up very little. Now, so that stretch of 5 really made this grow there. What do you do with each of those dots? Move them up 5, which is what? The way I set mine up, 1 box. And the one up top, I'm just guesstimating. Now, question for you as you start to draw this. As you draw this graph going off to the right, what is it you are never crossing or touching officially? Is it still the x-axis? It's the line that's 5 above the x-axis. Because normally it's the x-axis which has a value of 0, right? When you push everything up 5, it's no longer the x-axis that I'm not crossing. It's that what appears to be the first line, but it's labeled as our 5 line. So notice my attempt at not letting it cross. Normally it'd be y equals 1. The way we have this labeled is y equals 5. Yes? The what now? The reason for the why we're not crossing the 5 line? No, it was for the moving up 5. You know, bad design, having 2 5s in the same problem. No, it's because we took the graph and we moved it up 5. The stretch does not affect that. Good question. Okay. One quick equation to go through. And then I've made it through what I wanted to make it through. Yesterday, or the last 2 days, didn't mean to zoom that far out. The last 2 days, we worked with an exponential growth and decay equation, right? And basically, that is compound interest. Okay? Where, you know, that interest is compounding maybe quarterly, maybe weekly, but, you know, annually, whatever it is. Okay? Now, we have a different formula, and this is specifically for if interest talks about being continuously compounded. So if you're in a situation, it says that the interest is compounded continuously, you're going to use this equation here, which is A of t equals P times E to the RT. Okay, do you remember from whenever you last did this, what's P stand for? Or it says it right there. Principal, yes? Which, what do we mean principal when we talk about money? Yeah, it's your initial value. It's the amount you're depositing. R is still the interest rate. It's the annual interest rate. And of course, we're going to be using it in the decimal form. T, as always, is time. And A of t is the amount or balance at time t. Okay, let's do the first example here. Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. How much will you have in the account when you enter high school 4 years later? Okay, I'll be back in a moment. What kind of interest is this? Yeah, it specifically says in there, continuously compounded, which means, what's the formula we're going to use? The one that we're given, yes? Sorry, the computer is being identify in the given equation, or in the given problem. Okay, you started with 3,000. That is our principal. What else do we know? Okay, 5% annual interest rate as a decimal, 0.05. And, yeah, they're asking about 4 years later when you enter high school. They're not even making you do the math of figuring out how many years that is. They're telling you 4 years. Okay, so we are essentially finding A of 4. And realize, when I write that A of 4, I'm not saying you're going to have to do anything with that 4. That's just indicating that we're finding the amount after 4 years. So 3,000 times E to the 0.05 times 4. Now, the cleanup I would start with, to kind of make life better, 3,000 e to the, what power is going to be on e? What is 5/100 times 4? 0.2, 2/10. Now, for most of you, I would say enter this on your calculator from here. Otherwise, if you have a calculator, you have to break it down into more steps. Start with doing your e to the 0.2 power, getting that, and then multiplying by 3,000. Now, with that in mind, you guys know anything about e?
Typed it in and it worked.
You typed it in and it worked. Okay, so on your calculators, you will have e, okay? E is provided on a scientific calculator, and I'll help you find it. E is an irrational number like pi. You know pi is 3.14, yada, yada, yada. Well, E is escaping my mind. 2.7 something, yada, yada, yada. Okay, but here's the good deal. I have an E on my calculator. And how a lot of you will show, mine is over here on the left, and you notice my LN button. Right above it says E to the X. There's my E button. You have something somewhere, okay? And just for showing you, if I just do e to the first, there is the value of e. It's what's called the natural number in math. E's value is 2.718281828, so on and so forth. It's irrational. It goes on forever. So if I'm doing 3,000 times e, so I do my second function, and I'm doing to the 0.2 power. Does your answer match my answer?
Yeah.
If so, you figured out how to use your calculator. If not, we need to figure out how to use your calculator. Okay, but any scientific, a graphing calculator is going to have the E button on there also. A basic 4 function, I can't say that it will, but.
So it's literally a number of my
Yep, it has an assigned, that is its number. Now, $3,664.21. Because, of course, you're going to give this to me in dollars and cents. Okay. And that is a perfect place to stop. Have you read the next problem? 4 more years of high school. So you would do what? You would put 8 in instead of 4. Okay? Again, it's just practice there.
What fifth grade ever? It's like, if you win, it's like talent show, you get $3,000.
Okay. Your homework is lesson 7-2 in Math Excel. Get it done for tomorrow. We haven't had that happen a lot lately where it is due the next day. So get it done for tomorrow. Yes? Can I what?
I'll do it.
I can try. Your calculator is different, but I will definitely help you figure it out.